Hello, everyone. Nice to see a lot of old faces. Francois, I've not seen you in a while. It's great to see your face. Um, Thanks to everybody for attending this, and a special thanks to Matt for doing all the hard work of organizing it. I'm going to talk briefly about the history of BOINC, about my personal goals for what I want to happen with it, and some of the activities over the last couple of years that I've been involved with. So I created the BOINC project a long time ago in 2002 to make it easy for scientists to create volunteer computing projects, sort of inspired by the SETI at home model. And BOINC has been supported by a series of grants from the National Science Foundation. I wrote most of the client and the server code and also the web code with a bunch of help from some people here today, like Kevin Reed and Bruce Allen. And I was able to hire a couple of employees, Rom Walton and Charlie Fenton, who did the rest. Rom wrote the BOINC manager. Later, Joachim Fritsch wrote the Android GUI, and later Vitaly Koshura rewrote it. Of course, the BOINC code is open source. The copyright is held by UC Berkeley. The whole idea of volunteer computing is that the vast majority of the world's computing resources are in consumer products. At the beginning, it was PCs, and now it's moving out into a greater diversity of things, like appliances and cars. And scientists, for the most part, use organizational computing resources like supercomputers and clusters. The idea of volunteer computing is to give them access to this much larger pool of consumer computing resources. And the gap is really quite large. The supercomputing world is currently trying to build an exaflop supercomputer, but if we were able to harness all the consumer products in the world, we would have tens of thousands of exaflop computers. My goal from the very beginning and through today is for volunteer computing to be what I call huge. By that I mean that the volunteership is in the range of millions or tens of millions or even more, and that computing power should benefit a lot of scientists, hundreds, thousands, however many there are, I don't even know. And that by doing so, we can potentially enable new science that couldn't have existed before without volunteer computing, and in particular, enable new scientists, especially in poorer countries that don't have access to the big computing power that we do here in the US and Europe. And as a side benefit, to increase the public's awareness of science, and also to try to involve the computer science community in volunteer computing. I think volunteer computing is just a great source of interesting kind of theoretical problems that would be good to have a lot of smart people working on. But volunteer computing has not become huge. It kind of reached a peak in terms of participation in the early 2000s and has been gradually declining ever since then. So here's a graph of active volunteers from one of the BOINC statistics sites. I'm not sure where the jump there is from, but in general, there's this trend that has continued for years and years now of a gradual decline in volunteership. And the number of scientists using BOINC, maybe it hasn't declined, but there's turnover. It certainly hasn't increased. Folding at Home, which started around the same time as SETI at Home, has, I think, done a better job in a couple of respects, and its volunteer base is declining more slowly than ours, and its computing power has surpassed that of BOINC. And folding at home is great. I have nothing against it, but it serves only one research group, kind of basically kind of one professor and his academic descendants. So from the beginning, I designed BOINC to be an open system. There are a lot of pieces to it. There's the central parts are the client and project software, which is what distributes and executes jobs. But then there's a lot of kind of add-on pieces of software and various systems, like the GUI. There's a choice of GUIs, and anybody can go in and develop a new one. There are account managers like BAM and Grid Republic. There's sites that show statistics. These days, there's people basing virtual currencies on BOINC credit. These different parts are connected through documented RPC interfaces, so that anybody can go in and develop new examples of these things. And based in this architecture, a lot of pieces have been developed. There's various account managers. Companies are using BOINC for different things. If you look at the kind of the BOINC world in terms of people and projects, there's a lot of components to it. Then of course there are developers who contribute to the BOINC source code or develop their own independent pieces of software. There's the 100,000 or so volunteers. It's important to realize, for me to realize, that not everybody in this world has the same goals as I do. Like I said, my goal is for BOINC to be huge, and the things that I do, like for example, promoting Science United on the BOINC website, are in pursuit of that goal. Everybody else in the BOINC world may have different goals, and I encourage and applaud all these activities, even though in some cases they conflict with my goals. In 2016, we created the BOINC Project Management Committee to coordinate these various activities. I think there was some initial uncertainty about the exact role of the PMC, and it's kind of converged to having the role of providing communication channels between all the different pieces in the BOINC world, and doing things like the developer and project calls, which are Zoom-based calls where groups of people in specific areas can talk with each other. Let me talk about what I've been doing the last few years and some ongoing stuff. In the world of scientific computing, there's kind of an establishment, and the establishment involves things like supercomputer centers. So here in the US, we have TAC and the San Diego Supercomputing Center, Illinois, and so forth. There are various kinds of grid activities. One notable one these days is called Open Science Grid, which gives scientists access to about 100,000 CPUs at about 100 different institutions using software called Condor. And there's an organization called Exceed here in the US for managing, for giving scientists access to these various resources. You can apply for a grant, or you can buy time on them. So in trying to get more scientists using BOINC, I've been trying to kind of move BOINC more into the mainstream of this world I'm describing here. So in 2016, I got a grant from NSF to pursue this, and there were a few products from that. One was a project called BOINC Attack, which I think we're going to hear about later today, which is based at the Texas Advanced Computing Center. And the idea is to take the jobs that would otherwise be run on their supercomputer, but which don't actually need a supercomputer. They're sequential jobs that could be run on a single computer, and to offload those to BOINC and to free up the capacity of the supercomputer. The second of these projects is based at a science portal. A science portal is a website where scientists in a particular domain can interact and share files, and in some cases do computing. It provides web interfaces for submitting batches of jobs. The oldest and biggest of these is called NanoHub. It serves the nanoscience community, and we added a BOINC backend to NanoHub, which greatly increases their capacity for doing batch jobs. In both cases, the idea was that we would create success stories so that other supercomputer centers and other science portals would say, you know, that's really cool. We want to do that at our site as well. Well, both of these projects were successful. We got things working, but there haven't been any follow-ons to that. Maybe there will be in the future. The other thing that I worked on as as part of that grant was Science United, and the kind of the top level goal of Science United was to lower the barrier of entry for new projects, for scientists considering using BOINC. And the main idea was to remove the necessity to create a website or do any recruitment of volunteers. A new project kind of automatically gets a pool of volunteers based on what science area they're in. And this provides the ability to guarantee a project a certain amount of computing power before they even exist, before they invest the energy in learning how to use BOINC. And I'll talk more about Science United next week. In the past couple of years, I've been involved in partnerships with a bunch of different companies that I'll just kind of go through here. Xiaomi is a Chinese cell phone maker. I think they're the second biggest one. And they, as part of the launch of their new high-end phone, came to me with the idea of bundling BOINC with a phone, putting it in their app store, which is, you know, kind of a Chinese counterpart to the Google App Store, and promoting BOINC. They wanted a kind of a custom version of the BOINC client that would show a particular splash screen with some text on it. So Vitaly and I managed to do that, to make a custom version, to get it into their app store. I don't think that they've really followed through on it, because I'm not sure we've gotten a big influx of Chinese users of the Android client. About a year ago, I started working with a Japanese car company who wanted to run BOINC on the in-car computers. These are electric cars. The idea is that it would compute when the car is in the garage plugged in at night. And that this project is going along. I think it's going to happen. In this case, the computing power in the cars is pretty minor. But then more recently, I was approached by a Chinese car company that makes self-driving cars that have a lot more computing power in them. And by a lot more, I mean in the neighborhood of 50 teraflops. Those are basically 4 high-end GPUs. And even more interestingly, the processors have kind of AI accelerators which measured in a unit called TOPS, or tera tera tensor operations per second. They do 1,000 teraops, and those operations are integers, so we shouldn't confuse those with flops. But basically, each car is an incredibly powerful supercomputer, and they're connected over 5G. In the future, it's quite likely that the average consumer will have much more computing power in their car than in all the rest of their belongings combined. So these are potentially exciting partnerships. We've been working with Leyline, which is an effort to incentivize BOINC users with in-game currency and things in video games. And we're using Science United as a way to measure the amount of time that people's computers are on, which is the basis for the rewards. A company that makes robotic pets approached me a while back. These are little things that look like dogs that have conversations with you and have a lot of computing power. I'm not sure that's going to go anywhere. Recently, I was approached by a British water heater manufacturer in which the controllers have sort of Raspberry Pi level computers in them, and they wanted to run BOINC on their water heaters. And these days, every appliances are increasingly intelligent, which means that they have processors and they're potentially internet connected. So we can run BOINC potentially on everything. IDLE, which I think is going to present later today, I'm advisor of, though I haven't actually given any advice yet. SUNET, this Chinese group that wants to make a virtual currency based on BOINC, they sort of dried up and went away, but recently they found a new source of investment, and they're back again and talking about resuming what they were doing. So as with all partnerships involving companies, everything here is kind of iffy. Most of these things sound good at first, but they don't actually pan out. But who knows? Maybe some of them will. So these are interesting directions. So just to wrap up here, BOINC certainly has not lived up to its potential. There are these huge numbers of what we could do with all the computers in the world, and it's not happening yet. But I'm happy that we're all still here and still trying, and who knows what might happen. So that's all I have. Thank you very much.
Okay, well, thanks very much, David. So now we get the potentially technically tricky part. Let's give it a go, a quick Q&A session. What we'd like to do is to have people use the hand raise feature, which is at the bottom of your Zoom window under reactions. If you click reactions, you can raise your hand, and then we'll call on people one at a time. So let's see, we have one. So let me, oh, no. That hand raise went away. Anybody else have any questions for David? It was quite a lot of material and a lot of goings on. Well, okay. Well, thanks, David. Oh, hold on. David, if you
Yeah. Hi, David.
Okay.
Yeah. Hi there, David. So you mentioned about Mixergy and water heaters. You know, I'm interested in what their possible model could be. Just if you could just say a little bit more about that. David's still muted, by the way.
That's surprising. Hold on. David, can you now unmute yourself? Sorry for the technical difficulty. Okay, now David, you should be.
Yeah, Matt, I was getting a message saying the host is not allowing you to unmute yourself.
Oh, and I was clicking to unmute you, so go figure.
Yeah, I think their model is, PR and good of humanity. They are based in Oxford, in your neck of the woods, and I'd be happy to forward their contact info to you.
Okay.
That'd be great, Dave. Thank you very much.
Sure.
Just a quick question for you, David. Were you automatically muted in some fashion when I switched to David, or did you mute yourself?
I had muted myself.
Okay, David Wallum, I mean, because seems like every time we switch, people are getting muted, and that's not supposed to be how it works. That's not how.
Does anybody know American Sign Language?
No, so there's somebody in the chat who's saying he's got a question. So let me unmute Maddie. Maddie, can you unmute yourself, please?
He doesn't have an audio channel.
Oh, I see. He doesn't have a microphone. Maddie, do you want to type in your question into the chat?
Yes.
So David, Maddie asks if there are any plans to collaborate with Gridcoin.
No specific plans. I think we added a feature to the BOINC web code at their request to let people authenticate themselves. I'm not sure what other collaboration you're asking about.
Maddie, does that address your question? Any follow-up? Okay, well, last chance for hand raises. Otherwise, we've got a packed agenda.